Okay, welcome to the fifth practical of Object-Oriented Programming 1. Let's see what we're going to do today. We today have a lot of organizational matters, and then we will briefly discuss Git branches, because this is relevant for your teamwork in assignment 2. And then 2 weeks ago, the lecture team taught you about exceptions, and today we will recap them, show you examples there. And then in the end, we also introduce a new data type, STD optional, which is maybe also an alternative to exception in some cases and quite useful, I think. But what is on our organizational list today?
Okay, so the first thing, homework 2 again is due next week. So don't forget that. I think we said everything. We said many things about it already last week. Then, since you now completed assignment 1, all of you who passed 50% of the public test cases are now able, or later, to register for a team.
Yeah, so starting from 7 p.m. today.
Yeah, and it's also possible that you do not register for any team, then you won't get any grade in the practicals. So no negative grade, just no grade. But if you register for a team, then you will receive a grade, whether it's a positive one or a negative one.
Otherwise, if you register a team, then we really think that you're committed to do the remaining part, and it would not be nice if you register to a team and then later on decide, I don't want to do it, and your other colleagues have to do everything on their own. So decide now if you want to do the teamwork and continue. There are 2 options in the team selection. If you already know with who you want to team up, then just register to one of the, 100 teams that are provided in the Teach Center, and then you will stay as a team of 3. If you do not know other students quite well at the moment, and we should assign you to a team, then you can register for the group for students without team. And after the deadline of the team selection, we will then group you in teams of 3, or also fill up the other teams if there are just 2 people registered. And there's then no need that you really find a team on your own. Yeah,
maybe because this question is also often, you have to do it in groups of 3. You can't do it alone, or in groups of 2. You have to do it in groups of 3. And if you're just 2 in your team in the Teach Center, then we'll probably assign you a 3rd member from this group.
Assignment 2.
So as you already said, assignment 2 will start today, more or less. At least the kickoff video is available today, and the upstream and the assignment description will be available. But because we don't know the teams yet, because you still have to register, you do not get any personal repositories yet. And also, I don't think the test cases are available yet, but you can start looking at the assignment description.
So you can basically also have a look first and then decide whether you want to do assignment 2 or not.
Yeah. Then there are 2 necessary conditions for you to pass this course for assignment 2, because we want you to at least implement something, and this is 50% of all test cases. And there are also test cases which are marked with minimum requirement, or I think it's just 1 test case.
Yeah, I'm not sure, but there are 1 or more.
And these you have to pass. There can be memory errors, so passing a test case just means that you have the green check in the test report, but you need to pass this test case with the which is marked minimum requirement, or else you won't receive a positive grade.
But basically, if you do not pass the minimum requirement test cases, it's probably impossible that you have 50% of all test cases. So that's
and this minimum requirement test case also is just to group the test cases better. So basically, this additional condition also makes those test cases a bit nicer for you. So it's not like we're making it more difficult.
And a few more things on assignment 2. Assignment 2 is a teamwork, as we said. That's why we have the team selection phase. And the important thing is work as a team. So we don't want that someone of you in the team does everything on their own and the other 2 are just doing basically nothing. We would like you that you distribute the work as evenly as possible in the team. Yeah. And we also use a tool to check that. So we have the Git reporter, which you can also view in the pipeline. So next to the test report, you can also download the Git report. And there you get an overview of how much everyone in the team has contributed so far.
Yeah, and the contributions you do really need also to be from you. So you need to commit them from your own machine, and you can't like do the whole assignment where 3 of you sit in front of one laptop. Each one of you has to complete some part of the assignment, and we also need to be able to see that with the commits on the repository.
Yeah, and basically in the Git reporter, we then group the commits by person and check how much is done by everyone. Of course, this is not always the truth because maybe some tasks are harder to solve than others. So it should be like a guideline for you to see, okay, it's working out rather good, or maybe this person should do more. But of course, if there is something much more difficult than other stuff, then we will also consider this in the grading later on.
Just for a rule of thumb, the Git reporter provides you with a row which just displays how much code everyone has written, so excluding comments and formatting and stuff like that. And if every one of you has approximately 25%, at least 25%, then you should be fine.
Yeah, and regarding teamwork, we will also show you a bit more than with working on Git as a team. Last but not least, after assignment 2, I don't want to go into the full details one more time, but basically, if you pass the minimum requirement and 50% of all test cases, then you have 2 options. If you're doing really well, then of course you will continue with assignment 3, which builds on assignment 2. However, if you do not pass the necessary conditions, or if you're like rather close to the 50%, we suggest that you do the A2 correction, where you continue working on A2 and have then a second deadline where we then grade your assignment.
Yeah, so even though this 50% might seem much, I don't know, you have 2 chances to really fulfill these requirements.
Okay, that were the... Were they? No. One more thing, which is maybe nice to you. We will use C++20 for assignment 2. And as we said last time, for example, the contains function for a map is only available in C++20. And there are also some other nice features. Mm-hmm. But
you need to be careful because VS Code does not by default use C++20 when you code in here. So it could be that if you type make run to compile your project in your terminal, you get different errors than VS Code displays you in line. But you can easily fix that. I think the settings are
preferences.
Settings, you go in here, and then just type search for standard. And then here, C++ standard, you can choose 20 in here. And then, the errors you see in VS Code, when it underlines something, should be the same as when you compile in the terminal.
Okay, any questions regarding the organizational matters? Seems very clear. Then we start with the branches. So now, how should we do teamwork? So if some of you already did design your own app with us, so the Learning C group, then the next 4 slides are pretty much the same. So you can, for 5 minutes, don't listen, or listen to repeat this for everyone else. This might be interesting. Maybe think back when you were at school and did some team project on some topic, whatever, and then somebody did something there, and then how do you share the project to the others, and then maybe uploaded it on Dropbox or some other drive, and then everyone downloaded it and created a new version, and now two changed simultaneously something, and now what did who change, and how can we put them changes together? And yeah, Git branches are very nice for that, to solve these conflicts there. And basically that's why Git is done. So what is the goal with so-called Git branches? So on the very left, there we have the green dot, which states master or main. And this is like the main branch that you always used in your projects. And in ESB or in assignment 1, you just followed the green line. Yeah, so you had like, this was the state of your repository when you started, and then you did some changes, uploaded them to GitLab, did this one more time, tested the pipeline, and so on and so forth.
Yeah, so basically the dots are your commits in the repository.
But now what happens if two people want to do changes to the same thing? Yeah, because maybe you want to implement something, you want to implement a zoo class, and I want to implement a shop class. Yeah, and now I do changes, you do changes, and now how can we deal with that? And one option is to introduce like a branch, so a Verzweigung, and with that we separated our work. So you can now commit one, two, three things on your zoo class, and maybe I continue working on the main branch with 2 commits on the shop class. So during this phase, we don't need to take care what the other one is doing, so we can do our own stuff. And then at some point we say, okay, you are done with yours, I'm done with mine, now we need to merge it. And then we say, okay, we take the last commit of both of us, and then we want to create a new commit where both changes are combined. This might be tricky, because if we change the same part of the code, then maybe this will lead to a conflict then, and we need to sort it out. But at least during our work, we did not have conflicts. So with just one large conflict at the very end. And I think this is very reasonable to use that also in your project, that everyone does it on their own branch, and once something is finished, you then merge it in the master branch. So probably it's a nice thing if you just, on the master branch, you don't do anything except for merging together. And if Julia does something, she creates an own branch, do it here. And if I do something, I create an own branch, do it here. And then we merge everything together later on. It's like 3 commands or 2 commands even on Git. So with checkout, and then you specify the branch name, you can go to another branch. So this would basically mean I switch to the blue part here, for example, or back to the green part. If I also specify -b, then I do not only switch to it, but also create it. So we need to do this at the very beginning. And then maybe the command which is most challenging, because when we merge something, then after we type this command, we need maybe manually compare the versions and find the suitable combination of them. So with git merge, if I would type git merge blue, so I would do this here. If I'm at the third green node, I would type git merge blue in this case, and then the changes of the blue are merged with the changes of the green, and a new commit here is created.
Yeah, and maybe you also don't wait too long with merging your changes, because if every one of you does many changes, then merging them together can become more and more difficult. Maybe something because of the Git reporter, or not just because of the Git reporter, but because we need to see your commits. When you merge something into a branch, if you do it with the UI on GitLab, then there is some button squash commits. Please don't check that, because then we won't be able to see your commits in the main branch, and we can't really tell how much each one of you did.
So basically, if we would squash it, then the blue commits would disappear. Yeah, so don't do that. Okay, Maybe we demonstrate this also on a brief example. Yeah, okay. So now on the left side, it's me. On the right side, it's Julia. Assume that this is your laptop and my laptop and Julia's laptop. And now maybe we work on this main.cpp file. And yeah, I already created this hello world. And if I have a look here, Julia does not have the hello world yet. So I will just commit this. So let's check first, git status, okay, one new file, git add main cpp, maybe call it init hello world, and we push the changes. So I'm done now.
Yeah.
So now how can you get the changes?
Yeah, because we are both right now in the same branch. We didn't create anything yet. I am also on the main branch. Maybe I'll open the files here. And if I pull now, I can download these changes from that are in my current branch. So I'm in the main branch, and I can see, okay, Michi created this file here, and yeah, I see everything he did.
Maybe now you want to continue working a bit, and maybe you want also to switch to another branch directly.
Yeah. So we said with checkout minus B, we can create a new branch. I don't know what I want to do.
Just call it Julia in this case, maybe. So you can give it like meaningful names in the sense what you're doing. If you just write your name, probably it's enough.
It's probably better to give the branch name something like shop. If you're implementing the shop class, then you work on this and then you can merge it back. But yeah. And now maybe I'll create some additional function. Maybe something like this.
Mm-hmm.
And now I want to push it.
Yeah, okay.
So I'll add the file. I'll commit. And then I'll push it to GitLab.
Oh, what's that?
Okay, yeah. So I just created a local branch in my local Git repository. And this branch is not yet on GitLab. So I'll need to tell GitLab which branch I would like to push to. So it already tells me the command here. It just says, okay, I want to push into a new branch that I just created.
So like what you need to do is already displayed there.
Yeah.
So if you see this error message, please first read through it and see whether you get it, what it states, and don't post this error message directly in our Discord because it really states what you need to do. We often see this. Okay.
Yeah, and it looks like it worked. And yeah, do you want to try to pull this now?
So if I want to check out now the branch Julia, this does not work because why should I know that there exists a branch Julia? So I first again need to pull. Okay, yeah. But I don't have any changes here because I'm still on the main branch. But now if I type git...
You already see it here in the pull message.
So it also states here there is a new branch called Julia. But if I now check out Julia, then I have also the version of Julia. If I go back to the main branch, then I have the old version here. Okay, now let's try. Maybe we're doing something mean here and we do the same thing. Or let's say my function returns 4. So we're implementing something conflicting here. But I do it on the main branch, you did it on Julia branch, so it doesn't matter. We edit. We commit it, I don't know. And we push it.
Yeah, should I pull now?
Yeah, you can pull.
So I'm still in my branch here. And if I try to pull, well, nothing happens in here, but we can see, okay, there was something happened in main. So I can check out the main branch and
I need to
pull again.
Yeah, it also states it here.
And we can see, okay, f returns 4 now.
Okay, maybe we can try to merge your changes into the main branch.
So what we have to do now to get my changes, so the ones I have here, where I return 5, into the main branch, I need to actually be in the main branch.
Yeah.
We can see that on the slide. Here, merge branch into current branch. And if I want to get the changes from the Julia branch into the main branch, I need to be in the main branch and then merge this other branch into the main branch. Because the other way around would do the wrong thing. Okay, I can now say git merge and the branch name. And now we see, okay, here we have a conflict. Merge conflict in main, it tells us the file. And here in VS Code, it also displays this nice UI where we can see the merge conflict. And also it gives us these buttons if we want to accept the current change, which is in the main, or the incoming change of the other branch.
Maybe we accept the incoming change. So maybe you did the better job than me. Now we resolve this merge conflict.
Now I need to save it.
If you type now git status, what does it state? Okay, so we have unmerged paths. Yeah, so use git add, so we need to add it again.
And it also tells us what we have to do. We have to fix the conflict. We did that in here. And then run git commit to if we are done.
But we first need to use git add here for this file, I think.
Yeah.
Yeah?
Okay, added, committed. Yeah, okay, then I know which editor is this.
The Vim.
Okay.
And push it. Okay, and now the main branch looks exactly the same as the Julia branch, and if I pull again, then I see, okay, now I also have the 5 here in the main branch. Yeah, simple introduction. Your merge conflicts will maybe be a bit more complicated than ours. Do you have any questions, or should we move on?
Yeah, and really try, if you start the merge, also to complete it and or abort it. It said it above in the message that we can also abort a merge, but don't leave it in some weird state and then continue coding, and you can get all sorts of problems.
Okay, then we come to the first C++ topic, exceptions. And just a very brief recap, I think it's not really difficult. So we have 3 new keywords. We have the try, the throw, and the catch. So basically what we've done is we introduce a so-called try block. So we write try, introduce a new block. And yeah, we can write code as usual here. And then maybe at some point we say, okay, there is something bad happening. And then we can throw an exception here. So this means everything below this throw will not be executed anymore. And then we look, or we go on in the code and hopefully find at some point a catch block. So it states catch. And if this type here matches the exception we have thrown here, then we catch this exception here and can handle the error appropriately. If we never throw an exception in the try block, then we just continue doing everything here and we will skip all catch blocks below. It's just the basic syntax. Oops. And yeah, let's see what I have prepared. And at the very beginning, I want to do a bit, work a bit with the bad log exception, because this is really important to you. So maybe just create very simple a pointer, maybe a new integer with some value. Okay, this is nothing special. We compile it. And maybe I compile already with C++20, so don't forget to also write this if you do it on your by hand. And let's compile. Okay, we don't use it, but it doesn't matter. And if you run it, okay, everything is fine. We need to delete the memory. Okay, I don't care at the very moment. But now we said, okay, if a memory allocation fails, and I will trigger this now by allocating a very large amount of memory, which is too large that it can be handled. So let's call it large array, integer array, and I use this constant here. Or this constant is just so large that I cannot allocate the memory. And if I run it now, then I see, okay, my program does not run as usual, but it terminates after showing an instance of std_bad_alloc. So this is now an exception that was thrown because we could not allocate enough memory. And now what I can do is I can implement now a try block, and I will move the code here. And then we'll also add a catch block here. And I want to catch which exception, the std_bad_alloc exception. Maybe call it just exception. And what we can always do, we can always call the what method on the exception, which tells us the error of the exception. And I will just I don't need this, I think. Okay. If we run it now, we see, okay, standard bad_alloc is printed because we allocated too much memory. We catched here the bad_alloc exception and called then what on it, and this printed, okay, the type of the exception in this case. If I don't have this here, the large array, so all the allocations works as usual, then of course, this is not printed, and this is not the problem. Okay, now maybe I want to be a bit more precise with the memory.
Yeah, maybe you should delete it.
Okay, so maybe we call delete here on the pointer, and delete also the large array. I think I need brackets here. Maybe one question before, why can I not call delete here? Yeah? It's out of scope. Yeah, it's out of the scope of the pointer. So they just exist inside of the try block. Okay, so maybe switch them around for the moment. So I run it. Okay, standard bad_alloc, because this does not work. So what happens now, we allocate an integer here, or integer array, which is too large. We throw the exception. So this line, and this line will not be executed. Is this a problem? No, because we never allocated the memory for the large array. So we also don't have to delete it. We have no memory leaks. We can catch the bad_alloc exception and print then the error or whatever we want to do. But if I switch the order now around, then I have a problem. Because
maybe do we want to ask, does anyone see the problem that we have now?
Mm-hmm.
Yes?
Mm-hmm.
Yeah.
So the pointer never gets deleted is the right answer. And if we just go through it one more time, this works. Just one integer is not too much. Then we call large array. This throws the exception. So we will not continue in the try block, but we directly jump to the catch block. So we go here, print the error, but at no point this delete pointer was called. So this is a problem now. So because now we return from the main, but we haven't freed everything.
So how could we actually solve this? Because this now seems tricky.
Yeah.
Because outside in the catch block, we don't have access to the pointer, but we do not know if we need to delete the pointer before the exception is thrown.
Should I implement this?
Maybe try.
Yeah, right? I could. I haven't prepared that. So maybe make this a null pointer at the beginning that this variable already exists. Then I create another try block. I try to allocate the large array now. Okay. Then I catch this. Yeah, we can also copy this from here basically. So I catch the bad alloc exception. But now I do not catch every bad alloc, I just catch the bad alloc here of this try block. Yeah, so if this doesn't work, I catch the bad alloc. And now I can say, okay, I previously allocated the pointer, so I have to call delete pointer. I don't need to call the large array or delete the large array because this was not successful. So now maybe I can rethrow the exception. Because I want to terminate the program, it didn't work, I can do it with that. And now let me see if we move this away. So if you have the exception here, we throw the exception again. We do not delete anything further. We can do this. And then again, this exception is catched here because we catch it here, throw it again, catch it here, print the error message. It works. And if everything is fine, then we'll never execute the catch block, but we just call this pointer, or allocate this pointer and delete them. So this also works. Let us try. Okay, we print the std bad alloc. I cannot try it with Valgrind because Valgrind doesn't support exceptions in new. So trust me that it works, and I think it should work. But it's really ugly.
Yeah, because I think this looks now even worse than it did in C, because with every new call we have in here, we actually have to introduce one more nesting of these try-catch blocks to somehow handle the case that the second or the third or the fourth allocation failed and we need to free all previous allocations.
The solution is, we don't care. So it's enough if we do the following. We have basically a try block somewhere in the main, and if some bad alloc is thrown at some point in your program, you should catch it then in the main function, print error message. Maybe we also in the assignments always have some return code, so terminate the program appropriately, but we don't care if your memory is really deleted. In this case, only in this case. You
can't have any memory leaks. In any case, you have to delete all memory, always, except now in C++, at least in our assignment, when you get the std bad alloc exception. But there exists a nice solution.
Yeah.
And it's just because we somehow wrote a C-style program now in C++, and it looks quite weird now, but in C++ we have classes and destructors, so there actually exists a much nicer solution, because there's one thing: if we throw an exception and therefore exit a function, or exit this try block, all destructors of objects we have in this scope are actually called when we throw an exception, and we can use this to clean up all our memory, even if we don't know if the exception occurs or not, because if it occurs, the destructor will handle our memory, and if it doesn't occur, we still have our object. So this would be a nice solution. Do you want to implement this?
Yeah, let's implement that. And this is also a good, a good first idea for today's topic in the lecture. I want to implement something like maybe memory save int. Yeah. And now I just move so instead of allocating the pointer here, I just move the pointer up here. So we have here a pointer variable. And now I implement a constructor of the memory save int, which takes an integer, the value of it, and basically creates here the new integer with the corresponding value. And in the destructor, we basically delete the memory again.
Yeah. Maybe again
Delete.
a question to you. We are implementing a destructor now. What do we have to do? So we implemented this destructor in this class. Is something missing? Yes? Yes, delete the copy constructor. And in the future, you need to handle some third case that we don't know yet. So,
Okay, so we will delete this, and deleting is very simple here. Implementing is a rather hard thing, which we will see in today's lecture, basically. But we'll just delete it for now.
So basically, we're doing the same thing we did in the main with the pointer. We just allocate it in a constructor and then deallocate it in a destructor.
Okay, and if I now, instead of doing the pointer stuff here, I just create my memory safe integer, yeah, maybe int pointer, maybe, and initialize it to, what did I have, 42 maybe, and now I don't need to delete it here.
We also
move my line here.
Never need to delete it. So we don't need to delete it when we throw an exception because it gets deleted. And we also don't need to delete it if we do not have an exception because the destructor is called either way when it goes out of scope.
So basically, we create this variable here, and no matter what happens, at which point we leave the try block, we always call the destructor before. So it really gets all the time deleted. And if I do run this now, I mean, okay, we get the bad alloc here again. Again, I cannot check with Valgrind whether it works or not.
You could print in something in a destructor.
Okay, I can print something here.
So let's hope it works now.
So the destructor is called. So we delete also the pointer. This was never allocated, so we fixed all memory errors. Okay.
Yeah, so actually using the concepts that we learned in C++ and encapsulating our memory usage or memory management we have on the heap in classes really allows us to avoid having to do all these checks with the memory.
And also sum this up here. So regarding standard std bad alloc, so if there are no errors in your program regarding memory management, then please always delete all memory, and this will be also checked in the test cases. And if at some point the std bad alloc exception is thrown, you need to terminate the program. As stated in the assignment description, you need to print the corresponding error message. You need to return with the correct error code. But it is okay if not all memory is freed in this case. And it is then enough that you just have a single try catch in the main function. So put all your code in the try block and then catch the bad alloc exception. And then basically nothing should be possible in this case. Or, and this is much better probably, use what you learned in today's lecture, use the smart pointers. Yeah, so we'll see them in 1 hour, and they are really nice because then you don't need to think about memory management. Yeah. Still, you need to do this try catch thing in the main because also smart pointers there are pointers under the hood. Also there, this can fail, but you don't need to deal with deleting memory at all.
And maybe if you hear about smart pointers today, think about our memory safe int because there are some similar things about them.
Okay. Now we saw how to use the bad alloc exception or how to deal with them. And now we want to create our own exception class. And what is our goal here? I want to read a string from the user. So this could be like a command in assignment 1 or in assignment 2. And then we want to verify whether the command is correct. Also verify if the number of parameters is correct. And if one of those two things is not true, then we throw an exception, catch it, and then ask the user for another input. Okay, then directly continue here. Clean up a bit. Well, we start again with an empty main function. And I will also have this file OP exception prepared, which I will use in a couple of minutes. And I want to do something very silly, actually, but it doesn't matter. So the correct command should be like greet. I want to greet you, and how many people are there? Maybe 30. So this would be a valid command. So we have, so greet needs to be the command name and one additional parameter. Okay, now maybe something similar we have to the greeting simulator. So this is then somewhere in the main function, and then we start the simulator. Okay, or maybe you have an object here where you call to start it. Okay, and what we want to do here, basically we want to read in user input repeatedly. So maybe start with a while true here, and I create a string where the user input should be stored. We saw this already. We use get line from cin and store it into the input. And yeah, basically now we have the input, and now we want to execute the command. So maybe we have another function handle input here where we pass in the input. Okay, so one more function. Probably these functions are all in a command line class group together, but I don't want to put this in a class right now. We'll have maybe handle input. And maybe a first thing, we have a string here. Maybe a first string would be that we split now the input into several parameters. So that we again split the input on the spaces. Yeah, maybe I introduce something a bit new now to you. So I create a so-called string stream, call it maybe stream, and also need to include it. And I call stream.string on the input. What does this do? The streams were like cin, for example. Cin was a stream in C++. But also when you open a file, then you have a file stream.
Yeah, it's basically what you specify as a first parameter for getLine.
So this basically means I create a fake stream, so which contains the user input in this case. Or let's think about it as there is a file which contains exactly the user input. So it just consists of the string and like a fake stream here. And the advantage is here now that I can use the ascii getLine function again to read from the stream. In this case, I will then specify my stream and split it then, split the input then up on the on spaces. So where to store it? Maybe we introduce first a vector of strings with parameters. No, I didn't include string even before. Okay, so with the parameters, and this we also saw this in the practicals at the beginning. We can call getLine repeatedly in the while statement. We read from the stream. Okay, we need one more variable, unfortunately, a helper string maybe. And we want to split on a space character.
Yeah, so if you remember, the third parameter for getLine is the delimiter, which just means up until what character do we want to read from the stream. And for example, if we specify space, then if the user input somewhere a space, then we just read up until the space. So the same thing we do with \n. So with the new line, by default, we can also do with the space here.
So basically, if I have this as in the input, then on the first getLine call, I would get greet, and the second getLine call, I would get 30, and on the third call, I would get here false, so I would not continue here. Okay, now I store it in the helper variable, and I can just parameters push back what I have read from the stream. So with that, then maybe now let's try it. As in the parameters, maybe print s, just to verify that this works. Okay, compile. Run it, maybe 1, 2, 3, 4. Then I split it up in 1, 2, 3, 4. Or if I implement, I call my command, then I have greet and 42 as the parameters. So this works. Maybe also a tiny hint for assignment 2.
Yeah, but it's very similar for A1, where we already provided this for you.
Okay. Maybe we can do something now. If there are no parameters, if the parameter size is 0, maybe we say, okay, this is pretty valid, so just ask again, but it's not like an error. This is not an invalid command, not an invalid number of parameters. So maybe we'd return false here in this case. So I need here a Boolean. And otherwise I will return true, but I will see this later. But now to the interesting thing. So if parameters at 0, this should contain our command. Equals greet. Then we will do something with that. Sorry. Else, if it's not greet, then it's an invalid command. Let's write this here. And now we could throw an exception in this case. And now maybe we call it an invalid command exception. And in order to throw this is just an object, an ordinary object. So I want to introduce an exception class. And this is a class, invalid command exception. And a very good practice is that you always derive the exceptions from the STD exception. Because if you do so, then all your exceptions are also like ordinary exceptions. And if you just catch a STD exception at some point in your program, also your exceptions fall in this category. So I would recommend that you always derive from the STD exception. Okay. Maybe we need to include also except now that it knows the exception, and maybe create an invalid command exception. I think we don't need parameters at the moment. Maybe I will just I don't know. I don't need this. So just create the constructor here that this exception can be called. And I will also implement the what method that we've seen already before. So this is a virtual const jar pointer what const override no except. Okay, what it basically does, it returns a C string, it overrides it in the base class, it shouldn't modify anything in the class, and I think no except should be there because there is no exception thrown. Okay, and just return maybe some error message here. So maybe error invalid command. I hope I did everything right here. Have I done something wrong? No, I think it. Okay, let's see whether I did something wrong here. I did something wrong. So why is the invalid command exception not found here? Because I have not included it. So let's do that. Include the OP exception. And I missed this guy here. Did I do? What did I do wrong? So we have the constructor here, empty body. Oh, okay.
I think you need to put the no except before the override.
Ah, okay. Order matters. Ah, okay, override. Okay, yeah, so the no except must be before the override. Things you don't need to know. Things you can look up. Okay, so we have now our exception class, which just the what method returns just an error message. And now if the parameters is not greet, then it's an invalid command. We throw the invalid command exception. Okay, then probably if we throw it here, we need to create somewhere a try block where this is in. And I mean, if I create a try block here, this is not really meaningful because why should I do this here? And also maybe in this function, this is not the appropriate part where I want to handle this error. But I will do this one function outside. So this is the function handle import. Here the exception is thrown. So I will place my try block here now into the simulator, move the handle input here, and then I will catch my invalid command exception and maybe print the error message. So I can just call exception.what. Okay, and now this is handled. Okay, very nice. And parameters at 0 is greet. Okay, then check if parameters.size equals 2. So the greet takes itself one parameter and then the number of people that I want to greet. Okay. If it is 2, then maybe we do the right thing. Hi, parameters at 1 people out there. So then we print this message and everything is fine. And else, if this is not correct, then I maybe throw another exception. I throw a wrong parameter count exception. Okay, now I can create this very quickly because I just copy everything over here and wrong parameter count. Okay. Okay, one last thing. So the exceptions already work. We will test this also. I said I return here true. And then if this is true, then the command got executed. I can terminate the program. Maybe make here bool successful. Set it to false and set it to false. Then while we're not successful, we repeat this, and if handy input was if it was successful, then this is true. We go out of the loop. And otherwise, if we throw an exception, then we certainly do not return true here. So we go to the exception and repeat the part again. Okay, now let's try everything. Now compilation works. So, where we are now. So we are here now. We read in the line. Maybe I just enter nothing. In this case, we go here, we split it up, we say parameter size is 0, return false. This is not an error really. We just repeat it. So this works. Now if I type in maybe some command, then we go here, we split it up, check parameters at 0 is greet. Okay, this is not true. Else, it's an invalid command. We throw the invalid command exception, and the invalid command is printed, and this is printed here. And now if we call greet 1, 2, 3, what did I forget? Anyone an idea what I did forget here? So I throw, in this case, the wrong parameter count exception. And what do I do here? Yeah.
You don't catch it?
Yeah.
Catch the invalid command exception of the wrong parameter?
Yeah, exactly. So I also need to catch wrong parameter count exception in this case. One more try. If I call greet 1, 2, 3, this works. And now if I do the right thing and I greet all 30 of you, then prints it and it terminates the program. Okay, but now this is maybe a good point. Now we need to catch both of these exceptions here. And basically here we just have code duplication because this is the same thing. So one option would be,
to catch STD exception.
Yeah, so we can maybe do this. So we can remove this part, run it. I don't know, greet 1, 2, 3, and something. So it also does the right thing.
But maybe this is not the right approach because what happens now if we get the bad alloc exception, for example, in the handle input, somewhere in the memory is allocated and this fails?
So we need to distinguish the bad alloc exception from our own exceptions in this case. Because
what would happen now is the allocation fails, bad alloc is thrown, we catch it here with the exception, print, okay, bad alloc, but then we never exit the program. And because we just want to continue after an unsuccessful input. But if we have a bad alloc exception, we need to exit out of the program, and this would not happen because here with this STD exception we catch all errors, but we only want to catch the errors that are relevant right now.
For that reason, we introduce one more exception class, and I call this maybe just OOP exception, which I don't want to implement, which should be an abstract class. I will never create such an object. But now I can derive my other exceptions from this base OOP exception. So I will not derive them from the STD exception anymore, but I will do this here from our OOP exception. And since now the invalid command exception is an OOP exception, and also the wrong parameter count exception is an OOP exception, I can just catch here my OOP exception. And then, in this case, just our two exceptions are called here in the catch block, and no other exceptions like bad alloc or whatever.
And of course, in a bigger program, it would also make sense to make these distinctions and subclasses of exceptions even more fine-grained. For example, we could now derive a command exception from the OOP exception, and then derive these two from the command exception, which would have the advantage that here we can catch the command exception, but any other OOP exception, for example, something completely different that has nothing to do with the commands, can still be thrown, and we don't catch it here accidentally.
Okay, I think that's it. Maybe some good ideas for your commands parsing in assignment 2. I think I have one slide no, I don't have a slide to come up with that, but just again to emphasize is derive a base exception from the standard exception, and then from this base exception derive your own exception. This is quite beneficial. Okay, then I clean this up for you that you can continue with your topic. And
so we've seen multiple ways to use exceptions now, but maybe you don't always want to use exceptions. So I'll create some example. I just want to model a board game. And maybe I'll just call this board. So I want to create this board, and on this board I want to be able to place some piece of this game and maybe at some position. What I want is that here, for example, I have this player 1 piece, and I want to place this on the board, maybe as a pointer. Something like this. And, well, let's create these classes. I don't want to do anything with the board piece, because this is not relevant right now. But maybe let's look at the board. What I want to do here is I want to have an STD vector of these board pieces. Maybe I call this map. Yeah, let's call it map. Or maybe board. But not on every position in this board, because if I look at it like this, if I want to, in the constructor, create this board now, well, I want to make it 10 elements long, so I can create a vector, first parameter 10, the length, and the second parameter with which value all of these 10 elements should be initialized, but I want all positions on this board or all elements of this vector to be empty more or less at the beginning. And what I could do is just create a pointer. So we just store pointers to board pieces in my class, and I'll initialize at the beginning all of them with the null pointer.
So this is like a construct of the vector where first say number of elements and then how to initialize them. Okay.
Yeah. Then we also need this place piece at some position where I'll just on my board. We also need a piece. Something like this. Well, not a reference, I want a pointer. But something like this. Actually, I could do a reference and then dereference in the tier, then I don't need to do it here. Maybe a bit nicer. And I forgot the semicolon here.
Classical error.
Okay, so I have this. Maybe I want to place multiple pieces. So for example, I just copy this, 4 times. And 8. Something like this. So I'll always just have a pointer to this piece in those positions in my vector. Okay, well, first let's try to do something with user input. What I want to do is we input some position, and I want to somehow give back the position, the piece that is at this position to the user. And because I won't do this whole passing thing now, I'll just do it like this.
So not using my solution from before.
And, well, somehow I need to get the piece now, so I want the piece at this position. And I want to somehow get this piece from my position on the board. But I also want to be able to get a reference to this piece. So I do not want a pointer, I want a reference to this piece. And this get piece should have some ability to tell me, okay, there is no piece here. And we'll use exceptions for that, because if I want a reference, want to return a reference from get piece, I can return a null pointer or something like that. So I'll do something like this. If the board at this position is the null pointer, then I want to throw some exception, and I know I'll just throw a runtime error.
So this is a built-in exception. So
yeah,
you should then create an own exception, but we will not do this now due to time.
Yeah, something like this. But if it exists, then I want to return it. And we're returning a reference, so I need to dereference this. Because here I have pointers in my array, so I get a pointer back, but I want to return a reference, so I need to dereference this, but the reference still points to this piece, because a reference is something like a pointer, as we've learned. Now I can catch this, maybe something like this. We try to get the piece. Yeah. And then let's catch this exception. And if we get an exception, I think, yeah, I actually wrote something there, so I can just print what I wrote in here and the one in the runtime error. So this is just some basic stuff, as we've seen before with exceptions. We throw one, we catch it. Let's try running it. No. So let's look at the position 0. We have a piece there. Let's look at the position 1, and we have no piece on this position. Okay, everything is fine up to now, because, well, we used exceptions, but we only use them in some error cases. So here the user enters something wrong, and this is, yeah, we can use exceptions there, because this is really an error. But now I want to print the board. So I'll just iterate over all positions and do something like this again here, where if we have a piece at this position, so at I want to print X, for example, and if we don't have a piece there, just a space. Maybe I'll print some delimiters. Let me comment out this. Okay, why? Okay.
But, okay, yeah, do it like this.
You don't have any.
I have another hotkey for that.
So let's run it, and we can see, okay, this worked. We, on every position where we have a piece, we printed something. Does anybody see something wrong with this approach?
I see this so often in the submission. What could be wrong here? Because by definition, an exception is something that occurs in situations which should not happen.
So it's not really wrong with the program. It's more like we have some design issues with our program. Yes? Yes, we're using exceptions for the actual program flow, so for the logic of our program, instead of them just being errors. And we just want to use throw exceptions when there's really something wrong. But what we are doing here is here we expect to get an error. So we expect to catch an exception here because we do not expect every position to be filled. Therefore, we should think about something different, what we could return from this function here. Mm-hmm. Because we have some reference, a reference can't be null, a reference always references a value, but we somehow want to indicate, okay, there's no piece at this position. So what can we do? Well, there's something called SD optional. And as we have seen, these exceptions really depend on how we use our function. We didn't change getField in our class, but later on we just used it in a different way, and now we are actually using exceptions as logic in our program. Because we're not only throwing them when we get an error, but we are throwing them, we expect to get them. And this is something you can get deductions for at A2. So we really should only throw exceptions if there's something wrong, like the user entered something wrong. So, as the optional is the solution, this just represents a value which could be there, or it could not be there. So it's just a wrapper around another variable.
So it's basically optional if this value is there or not.
So, so it is either empty or it contains a value. What can we do with it? We construct, if we just call the constructor like this, the value will be empty. If we call the constructor like this, then it will have a value. Okay? There's has value to check if this optional contains a value or if it's empty. So there are just these two states. Either it has a value or it does not have a value. And then there is the value function which returns the value if it is available. Or it throws an exception if there's no value. So we can still get an exception.
But in this case, probably you should not directly call value and then decide based on whether there's an exception thrown or not, whether there is a value, because then we're like doing the same thing again, more complicated. So really use the has value before.
There are also some nicer things you could do. Again, as with the, I think with get line, we can write this optional directly in an if statement, and it is implicitly cast to a bool if it has a value or if it doesn't have a value. So it's like calling has value in the if. And we can sort of dereference the optional to get the value from the optional. But I think we should use the .value function because we can only do this when it really has a value. If we do this and we do not have a value, we get undefined behavior, which we want to avoid. So anything could happen. Well, and how can we use this now? We just can return this optional here from this get piece. And if we have a null pointer there, so we have no piece there, then we can just return something empty. I think I need to include it.
I included it, but probably need to specify the type.
Oh yeah, I need to specify the type of the optional.
The same as for a vector. It always needs a type.
Then maybe let's fix it down here instead of this whole.
But maybe in the if there is something, probably can you then?
Yeah, I want to get to this later.
Okay. I'm sorry.
You're spoiling everything. So what I want to do here is I get this piece. Then this now has the optional type. Something like this. And if this optional is correct, I want to print something. Now here we could, with piece.value, we could access what this piece actually is. And now in the else case, we can just print this. I hope I did everything correct with the parentheses. Good. Yes. We can try again. Maybe I lied to you. No.
Okay. Many error messages. Okay.
Okay.
But I think
the problem is that we can't have an reference in an optional.
Okay.
I'll go back to the pointer here, just for now. I didn't do it with a reference in the example when I tried it out at home.
Okay, so BB.
Yeah, now it works.
Okay, so we need to have
Yeah.
either a pointer or just an ordinary variable here.
Yeah, as you
Okay.
might have noticed, you also can create a vector of a reference. These are just some technical stuff you don't need to know. But if we try this now, then we can see it still works, even though we did nothing here.
Okay, so I detected this already. Why
Yeah.
can we do that?
Because you would expect we can do something like this. We should do something like this.
Again,
So because to call the constructor of the optional, because we need to return optional, and pass in the value we want our optional to have into this optional. Because on the slides we said to construct this optional with a value, we want to pass it to the constructor. But sometimes C++ does this in a smart way, and because we know we want to return an optional with this type, we can omit specifying the type here that we want to return. So just like this. We can also do this here, by the way. We can omit the type here and just write these empty parentheses here, and it will compile the same way. So this here is now, because it expects this optional here, just a call to the constructor with no parameter and with one parameter. And what I did before is I even left out these parentheses, because if you have something of this type here, you can implicitly cast it into an optional type which has this value.
so it's really comfortable that you don't need to explicitly call the optional here, but you can just return usually or like nothing in the case if there is no value.
Implementing this optional from a function which returns a value is really easy, because you don't need to change the returns, and if you want to return empty, just these parentheses, and everything just works.
Okay, and down at the main, it's just we take the return value, then check either if it has value or by just specifying the optional if there is something, and then we can access it, or we should not access it if this is not present.
Yeah. Okay. I think I won't do the extension now with optional in a vector, but maybe as a homework, we're using this null pointer here to represent that the piece does not exist. But of course, we could here just have a vector of optional board pieces, and then we do not need any pointers. So this would be, I think, the nicest solution. It's not that difficult. You could try this at home. Maybe I'll also put this version then on the slides.
Maybe this is also quite comfortable in your assignment too, if you have maybe a board, maybe something else, and then there are either a value or not, then maybe you can consider using that.
Yes?
If we're using this optional and we're using the size operator of the vector, are we getting the whole size with the null operator, or just the amount of pieces in there?
No, the size of the vector is unchanged, so it's still 10. Okay. Because there is still something there in those empty positions. It's just that it's an optional which does not contain a value.
I think that's it. Yeah, like 7 minutes too late, but good enough. So we introduced Git branches to you, and then talked a lot about exceptions. And now we saw the optional, which is, I think, really comfortable. So keep it in mind.
Yeah, maybe something really nice if you are using too many exceptions, that maybe for some things these optional are really better suited than always throwing in an exception. Okay, then thank you. And lecture starts in 7 minutes? 7 minutes, so at 5:30.